Okay, so in grade 11, you will taught this formula. Average gradient is equal to f of x. Well, let me start from the basics of the formula to avoid confusion. Y2 minus y1 over x2 minus x1. So you did that formula from grade 9. But if you are dealing with functions like the quadratic function, the exponential, functions that are not linear, we have to talk about the concept of average gradient. Okay? Then, when we introduce function notation, y2 becomes f of x2, and y1 becomes f of x1, and this is all over x2 minus x1. So this is the concept of average gradient. These two are interchangeable, but when you are dealing with nonlinear functions like a quadratic, exponential, and so on, we're supposed to use the second one. All right? So when we bring that in now into calculus, you need to know that the average gradient of a curve or of a function between any 2 points can be determined by drawing a straight line between those 2 points. And then we will estimate the gradient of the curve or of the function using the straight line joining the 2 points. So here, if I were to ask you to determine the gradient of function f between point A and point B, it will be impossible for you to calculate the gradient along the line AB, because AB, I'm talking about along the function, this line here, is not a straight line. But we can approximate that gradient by drawing a straight line joining this point and that point. And that straight line is the one in green that I'm drawing. So if you draw a straight line AB, you can use that straight line AB to estimate the gradient between point A and B along the given function. Okay, so in that case, the gradient, or rather the average gradient of that function will be equivalent to the gradient of the straight line AB. Right? So here, where there is x2 here, we will put B. Where there is x1, we will put A there. So that for this question, our average gradient, MAB, it will be equal to f of B minus f of A all over B minus A, where A and B are x values, and B is greater than A. Okay, so this is how you write the formula using function notation. Formula for the average gradient using function notation. For our graph here, it will be given by that formula. Now, it is very important for you to be aware that your knowledge of function notation is extremely important in calculus, because calculus uses function notation even more. All right, so this is where we start. Now, this concept of average gradient, we are going to expand it, okay, and we include the concept of the limit to try and explain it. Now, moving on to the next page. All right? You okay? All right. Now, we can come up with a general formula for the average gradient using function notation, and this is how we'll do it. So if you've got another function, this is more like an exponential function. Okay, it's not the exponential because that point is going up, but it's a nonlinear function. So at point A here, the value of x, we can call it x. At point B, the value of x there, we can call it x plus h, whereby the distance between A and B along the x-axis, this distance here, we can call it h. So the distance between the x value at A and the x value at B, we can call that distance h. Okay? That's the distance h. If we incorporate our knowledge of functions, you are to find the average gradient there. So it will be MAV is equal to f of x2 minus f of x1 over x2 minus x1. Okay? Now, just want to remind you that this formula is the same as saying y2 minus y1 over x2 minus x1 that you were taught from grade 9. Okay? But here we are trying to calculate the average gradient of this curve between point A and point B. As you can see, the line AB is not a straight line. So we are going to approximate its gradient using a straight line, and that straight line will be a straight line joining point A to point B. So if I substitute my x value in this case here, my f of x2 will be the value of x at B. So at B here, our value for x, okay, I'll write it as x plus h, and the value for y, it will be f of x plus h. Okay, and at A, the value of x there is going to be x. It's going to be x, and the value of y is going to be f of x. Remember, f of x is y. Don't forget that. So, when there is f of x2, I can substitute the value of x, which is x plus h. So this becomes f of x plus h minus, where there is x1, I'll put the value of x there, which will be x. So that will become f of x, right? Then where there is x2 in the denominator, I'll put x plus h. Where there is x1 there, I'll put x. As you can see, this x and that minus x will cancel out. So the formula will become f of x plus h minus f of x, and that will be all over h. And this will be our average gradient. Okay? So it's application of knowledge of functions together with function notation. Okay? And that's all that is from grade 9, grade 10. Okay? And maybe you can say grade 11, because the concept of average gradient comes from grade 11. Okay. So the basic idea here is that the average gradient of this curve between point A and B is given by f of x plus h minus f of x all over h, where h is the distance between the two x values. Right? It comes from the concept of average gradient. Okay? So everything that I'm going to do from that page originates from this formula. Okay? I'm going to explain how we can relate that to the differential calculus. Alright, the basic idea is, if you draw a curve, like in this case, the quadratic function that we have here, quadratic function f, okay? If you want to determine the average gradient from point A, or rather the average gradient between point A and point B, okay, you can draw a tangent at point A. Remember, a tangent only comes into contact with the function at only one point. So you draw a tangent. You can also draw other straight lines, including the line AB. Alright, now this is very important for you to grasp. It can be very tricky. What happens is, if point B moves closer and closer and closer to point A, what will happen is that the gradient of the function, okay, will get closer and closer to the gradient of the tangent. Okay, so as the distance, this distance here, we call it that distance there, that we call it x plus h, whereby h is the distance from the first x value to the maximum level, or rather to the largest of the two. The largest of the two will be x plus h. So is the value of h, which is the distance between the two x values at point A and point B, gets closer and closer to 0, the gradient of the function between point A and point B will become equivalent to the gradient of the tangent at point A. Okay? Now what that means is that if you want to calculate the gradient between point A and point B of that function, you can just calculate the gradient of the tangent, and the two will become equal. That will only be true as the distance between this distance between the two x values becomes extremely close to 0. Okay? That's what this is all about. Yes.
So that's not to become equal.
What?
So you say the tangents are not equal.
The function is quadratic. I hope you can see that our function is quadratic.
Yes.
Okay? So because it's not a linear function, right? As the distance between A and B becomes smaller and smaller, that is, as it approaches 0, the gradient of the function, which is quadratic in this case, becomes equivalent to the gradient of the tangent at point A. So what we are saying is that this point B is moving to the left until it gets extremely close to point A. Or rather, we're saying extremely close to point A. That is in the limit now. We're talking about the limit now. So, because of that, the gradient of the function becomes equivalent to the gradient of the tangent at point A. Alright? Are you following that? Hello?
Yes.
Right? So let's move on. So this is the diagram from based on what I was saying. So if the value of h gets closer and closer to 0, or rather when point A gets closer and closer to when point B gets closer to point A, the value of h becomes closer to 0. That is in the limit now. Because of that, we can write a new formula for the average gradient based on the concept of the limit, which I spoke about on Friday. And this is how we will do it. So we say the average gradient, okay? We know that the average gradient is equal to f of x plus h minus f of x all over h. But now, if the value of h approaches 0, the gradient of the function becomes equivalent to the gradient of the tangent at that specific point. Therefore, we can write this as m, right? We can write that as m equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay? But now in calculus, we have a way of denoting this gradient. Okay? Instead of using the small letter m to represent the gradient, we replace it by a new notation which is called f prime of x. So f prime of x is the same as gradient. Okay? So we can replace that m by f prime of x. If I do that, we end up having a new formula which is f prime of x is equal to the limit as the value of h approaches 0 of f of x plus h minus f of x all over h. Can you pay attention? And this equation is the famous definition of a derivative. We call it, can you stop it please? Alright, so that f prime of x, okay, we call it the derivative. This, okay, we call it the derivative. The derivative of f of x, okay, sorry, the derivative. Okay, it is also called the instantaneous rate of change. Okay, it has got many names, so we can call it the derivative of f. We can call it the gradient of the tangent line. We can also call it the gradient of the function, and it is also called the instantaneous rate of change of f at any point. Okay? It is also called the definition of a derivative from first principles. Put that away, please. Okay? It is also called the definition of a derivative from first principles. The first question on calculus when you write metric, it will be on the definition of a derivative from first principles. Okay? This formula, it is also provided when you write metric, you have to know that formula. Okay, so the next thing that I have to do now is to use this formula to do some examples. Okay, that's the next thing that I'm going to do. So from today, when you go home, you sit down, you memorize that formula. Yes.
For the previous two slides that you were doing, you need to know how to do the formula.
No. The derivation you don't have to know, but the concept you have to. Okay? You still have to know the concept of average gradient. That can also come in calculus. Besides your grade 11 function, the concept of average gradient also comes. Right? Any other question before I move on to an example? If you don't have another question, then let's move on to an example. Okay. This part here, it just explains some of the things that you know. At a turning point, the gradient of a function is 0. You should know that from last year, right? If a straight line is slanting to your right, the gradient will be positive, so we call this an increasing function until at the turning point. On the right-hand side of the turning point, the function is decreasing, or the gradient becomes negative. All right? You should know that. Okay. All right, let me carry on to an example. So, okay. So the question that you can get is a question like, determine from first principles the derivative of okay, let's start with a simple quadratic function. So we can have f of x equal to, well, let's start with 2x squared, like that. Now what this means is we want to determine a general formula for the gradient of f of x equal to 2x squared in terms of x. We want to determine what is the gradient of that function. Okay, this function is quadratic because of that. Okay, so the first thing that you do is to write the formula. If f prime of x is equal to the limit as h tends to 0 of f of x plus h minus f of x all over h. Normally, the formula has got 1 mark in most cases. Right? Just writing the formula correctly. I just need to emphasize this, that the limit part must be written on the right-hand side of the equal sign. Okay? And as I told you on Friday, you continue writing it until you decide to substitute. In this case, we are going to be substituting h equal to 0. Okay? So I need to determine what the value of f of x plus h is. I know that my f of x is 2x squared. So let me determine what f of x plus h is using my knowledge of function notation. So f of x plus h means where there is x there in the original function, put x plus h. I'm going to repeat that. What this means is where there is f of x, where there is x here rather, you substitute that x by x plus h. Okay? So what that means is in this function where there is x, I've already put x plus h here. That's why I've got this. And it's the same as that. Okay? So I'll say 2 times x plus h squared. I'm only substituting the x by x plus h. Then your knowledge of algebra from grade 9. So you need to simplify this. To simplify, you need to know that it's the same as 2 times x plus h times x plus h. And if I simplify, I can do it mentally. This is the same as x squared plus x plus h. And then another xh plus h squared. Okay? And I can finally write this as these two will give you what? What is x? To be 2xh. Okay? So, because of these two that I will get here, 2 times x squared will give me 2x squared. 2 times the 2xh will give me plus 4xh plus 2h squared. So, our value of, or rather the expression for f of x plus h will become 2x squared plus 4xh plus 2h squared.
So you want to simplify further into others.
No. We are only finding the expression for f of x plus h, not division here. Okay, then I'm going to substitute this trinomial where there is f of x plus h. Where there is f of x here, I'll put 2x squared. Because 2x squared is the same as f of x. And then I'll divide that by h. Then I'll carry on. Okay? If you want, you can do this simplification whilst we plug in there. But I don't encourage that because mistakes might happen. Okay? Any question? This is just algebra. Please, it's not grade 12. What I did here, it's not grade 12. It's grade 10 functions. Okay? Then, I'm going to carry on now and say f prime of x is equal to, f prime of x will be equal to, the limit is h, it's not x now, remember, it's h tends to 0 of what? Of this trinomial that I got here. This trinomial was that f of x plus h minus f of x, which is equal to 2x squared. Right? So you get 2x squared plus 4xh plus 2h squared. That's the value of f of x plus h minus f of x, which is equal to 2x squared all over h. Your knowledge of function notation is important. Knowledge of function notation is very important. Okay? Then I need to simplify that. I'm not going to substitute h equal to 0 as yet. I have to simplify. So this becomes the limit as h tends to 0 of Now when I simplify that, I'll get 2x squared plus 4xh plus 2x squared minus 2x squared all over h. Fortunately, this 2x squared and that minus 2x squared are going to cancel out. Okay? When they cancel out, I'm going to get the limit as h tends to 0 of 4xh plus 2h squared all over h. Now, when you get to this point here, never try to substitute h equal to 0 because the denominator will become 0. And you end up having an undefined gradient. So what you do is factor out h in the numerator. So if you factor out h in the numerator, you get the limit as h tends to 0 of h times 4x plus 2h all over h. Okay? Then this h here cancels with that denominator h. Alright? You get the limit as h tends to 0 of 4x plus 2h. Right? Now you can substitute. The moment you decide to substitute, you then have to stop writing limit as h tends to 0. So this must be stopped when you decide at that moment that, okay, now I want to substitute h equal to 0. So I made that decision. I'm happy with everything that I've done. So I'll say 4x plus 2 times 0, which will give me 4x. Okay, then I can say therefore my f prime of x is equal to 4x. So that will be my gradient in terms of x. This will be the gradient in terms of x. To determine the exact gradient, you need to know what is the value of x at that point. Okay? In this case, it won't be given. You will just be asked to determine an expression for the average gradient. And that expression for f of x equal to 2x squared, it will be equal to 4x. And that is in line with what is called rules of differentiation, which we'll talk about later on, maybe from Wednesday or so. Okay? So I've shown you an example how to find the derivative from first principles. Is there anybody who has got a question?